Welcome to my dear student. So today we are going to simulate the water hammering due to a valve closure. So for that we have taken simple one pipeline like this. So you can assume this is the this is our reference line, or this red line is the reference line. You can take the elevation is 0, and this reservoir, we have taken two reservoir, this one and this one. So this height is around say 25 meter head, and then one pipeline is coming to 0, then it is elevated to some elevation, and then again it is going horizontally, and then this is this head is lower than this head. Okay, so naturally due to the differential head, the water will flow through this path. Then we will close the valve, and we will see what kind of transient or what kind of pressure profile can develop inside the pipeline. So for that, this is the basically this we are going to simulate. So I am very fast, already I run it and very quickly I will show you the parameters which is to be set. So this is, as I told, the reservoir. Simple, here you set the this is the head, initial head. Okay, then this is a pipeline. So this pipeline we have set the it as 150 NB. Okay, and this is the speed. Okay, that wave speed. So this I have given just arbitrarily. Okay, this is this much during the transient. This will be the wave propagation of the which is that liquid will be propagating in this wave speed, and the pipe wall roughness I given 1 millimeter. And as I told, so here this geometry, the input geometry you have to select, because the profile is, it's not horizontal or not vertical, so it is to be selected LH profile, and here it is given, the table is given here. You see, as I told, at length 0 the reservoir head is 25. After some length this is coming down to 0. That means you can see this is, after this distance it is 0. Okay, and then again it is elevating. So this is, here it is 10 meter. Okay, so this is that, and this pipe, it is a straight pipe. Okay, so if you see, this is a 6 kilometer pipe. Here same, that wave speed I given the same, and this is 150 NB pipeline, and the wall roughness is 1 mm. Okay, I have used one vent valve. So these are the parameter you need to set. This is the, because for a power plant your thermal hydraulics is to be the study should be done on thermal hydraulics. So that's why you have to put the this heat capacity and all. So this Laplace coefficient I arbitrarily I put 1.4, and these are the parameter you need to set. Okay, this ambient, discharge coefficient, then discharge area, and the initial air volume and the residual air volume. This is to be set, okay, for a vent valve. So if you study detail about the vent valve, you can do that. And here this segment should be, the elevation is 25 meter, because it is connected, this connector is connected with the reservoir and that pipeline, and naturally this pipeline elevation is coming to end at 10, so this also to be 10. And similarly this is slightly I given is a 5 mm elevation, okay, and this is also 5 mm, and finally this is also 5 mm elevation, okay. Now coming to the valve. So valve I selected here as a standard butterfly valve, and as the pipe diameter is 150, so the valve dia also 150, okay. And these things, how the valve action table. So you see at t is equal to 0, so I am simulating, I will do the transient steady up to 200 seconds. So at t is equal to 0 it was fully open, t is equal to 1 also it is fully open, okay. Then at 30 seconds this is closed, then it is continuously closed till 200, if you can see. So first it was full open, then slowly it is coming to full close at t is equal to 30 seconds, and then it is keep on, it's the valve position remain closed till 200 seconds. So that only I need to simulate. So these are the parameter settings here. So then you have to go to mode and option, and here you have to select the transient mode. This transient mode you have to select. After that you have to go to the this is the fluid window. So here this is the parameter for the liquid I used here as water, but normally in a fast reactor that will be sodium, and all the parameter is to be changed accordingly. Now go to the time parameter settings. So the time steps here I given is 0.1 second, and the simulation time is 200. These two parameters you need to set. Now I will run the model. You click the calculate transient. Now you can see here, if you see the valve position, this is the valve position. As I told, at 30 seconds it is getting closed. Now if you see the discharge, you see slowly suddenly the discharge, it was, this is the discharge, if you see, okay. Now if I see the pressure here, how it is, so you can see, you see that pressure is going negative and there is a fluctuation. It's a transient, it's causing, this is causing the this will cause the water hammering, okay. Now you can see this segment also, how it will be the pressure, you see the same, this entire pipeline will be experiencing this much fluctuating impulsive pressure, okay. Now if you see this two pipeline, and if you see the pressure, so you see these are this blue line is the total pressure, okay. This is the total pressure. Now let us see these things by animation. let us see. You observe what is happening. You see, time is slowly increasing, and now see, it is going towards the closure, and you see how much inside the pipeline the same kind of things, the liquid, it will start to undulate in this fashion. Okay, so this is the, you see, the change of pressure, this kind of things it will happen inside the pipeline, inside the pipe. This will cause hammering. Okay, so now if you close the valve, if you here in the program, in the simulation, if you change the valve action table very slowly, then this kind of transient will not occur. Okay, so this is basically the people already, I think the training school people who came to my lab. In my lab backside there will be, in the dumping area, there will be some pipeline structure. It will be, maybe it is maybe 50 NB, 25 or 50 NB, no more than that, I think. Exactly I can't remember. There will be some piping structure and some tank will be there. So this same thing, it was valid. This model is benchmarked how it has done. So in this here we have put some like kind of floating balls by a rope. Okay, and it is tagged inside. It's a transparent pipe, and then this picture was taken. This picture was taken. Then it is the video was taken, and after that video was paused at every time, the required sampling time interval, and that how the ball, all the balls, it will be doing like this when the valve we are closing. Okay, so then at each time interval this graph was imported to MATLAB, and then it is plotted using Gravit, and the same kind of things we observed, what we seen here in the simulation. Okay, so this is a very quickly I explained. So now right now one ongoing course is there. So they are one of my student, Shoham Banerjee, from Indian Institute of Science and Technology. So he is doing that course, and basically this all we are evaluating for the piping structure, one fail-safe condition called leak before break. So that he is working with me. So I will request Shoham that whatever I shown very quickly I have shown, but you can do it very slowly and capture the video and send it to me to keep in my channel, so that the other student will be benefited. So this was all about a very small video, that how to simulate the pressure transient or the water hammering due to fast closure of a flow control valve. So we will explore it one by one. So similar way, if a pump is stripped, the what kind of transient, what may happen, all these things can be simulated using Wanda. So normally I used this tool and the Flownex extensively, and I am very much grateful to my senior from whom every time he used to guide, and I acquired lot of knowledge from him, Velusamy sir. So my regards to him for the same. So thank you so much. Thanks for your patience.